6 questions are there, very easy questions. The molecule which has non-directional bonds. Non-directional bonds are present in ionic compounds. The first option, cesium chloride, is the answer. Student may also think about barium chloride, but barium chloride is polarized due to high polarizing power of Be2+. Look at the second question. Which of the following is a favorable condition or factor for cation formation? High electronegativity, high electron affinity, high electronegativity, small atomic size. So in that the answer is low ionization potential. First option. What is the crystal structure of cesium chloride? But crystal structures, earlier you have solid state subject. We study sodium chloride as face-centered cubic lattice, FCC, and cesium chloride has BCC structure, body-centered cubic lattice. Just to mention that NaCl has FCC lattice. NaCl has face-centered cubic lattice, FCC lattice, in which the coordination number of Na plus and Cl minus is 8, 8. Both are 8. Actually, we have coordination number. We encounter with this word in 2 occasions. One is in chemical bonding chapter, the other is in our coordination compounds. In coordination compounds, whatever there in the square bracket, coordination compounds are represented with a square bracket. Inside a metal will be there, surrounded by some other molecules or ions. So the number of ions or molecules surrounding a metal in the square bracket called coordination sphere is called coordination number. So coordination number in chemical bonding, especially in ionic compounds, the nearest number of oppositely charged ions surrounding a particular ion is called coordination number. What is coordination number here in chemical bonding? The nearest neighboring oppositely charged ions. The nearest neighboring oppositely charged ions surrounding a particular ion. Surrounding a particular ion in the unit cell. In the unit cell is called coordination number. We already mentioned the coordination number of Na plus is 6 as well as Cl minus is also 6. What does it mean? Means each Na plus is surrounded by 6 chloride ions. Each Cl minus is surrounded by 6 sodium ions. So what is the meaning of 6, 6 in NaCl? Each sodium ion is surrounded by how many oppositely charged ions? 6. Similarly, each chloride ion is surrounded by how many oppositely charged Na plus? 6. So the coordination number is 6, 6. Similarly, in cesium chloride, the coordination number of cesium ion and chloride ion both are 8. The coordination number of both CS plus and Cl minus. In CS, Cl. Is equal to 8. So actually this is body centered cubic lattice will be like this. First you have to write a cube. Now this cube has 8 corners. 8 corners, 8 chloride ions will be there. And between these 8 chloride ions, there is at the body center cesium ion will be there. This is called BCC lattice. Body centered cubic lattice. At the body center, you have cesium ion. How many chloride ions are surrounding this? From 8 corners, 8 ions. That's why the coordination number is 8. What is coordination number in complexes? We can say in 2 ways actually. The correct way of saying coordination number is the last. What is coordination number? 2 only. Speak a little bit louder. Have you added to police?
Which consists of symbol atom. Coordination number consists of symbol atom. So coordination is like and ligands.
Repeat once again.
Coordination, complex complete coordination entities, symbol atom and ligands.
I am asking coordination number. We are talking about coordination entity with metal and ligands within the square bracket. That is coordination entity we are talking. Suppose K4, you have PCN6. This part is called coordination entity. In this coordination entity, 6 cyanide ions form 6 coordinate covalent bonds with iron. So 3, 4, 5, 6. Each cyanide ion donate a lone pair to the center metal ion. So the number of coordinate covalent bonds, around the center metal ion, the number of coordinate covalent bonds around the center metal ion in the coordination sphere, is called coordination number. So what is coordination number? It is the number of coordinate covalent bonds which are formed around the center metal ion. in the coordination sphere or coordination entity, which is represented in the form of square bracket. That is called coordination number. So the term coordination number, at how many places you encounter? 2 places. One is in chemical bonding, that is in ionic compounds. The second one is in coordination compounds. What is coordination number in case of ionic compounds? Around a particular ion, cesium ion, how many oppositely charged ions are the nearest neighbors? Nearest neighboring oppositely charged ions surrounding a particular ion is called coordination. What is here? The number of coordinate covalent bonds around a metal ion in the coordination sphere, which is represented in the form of a bracket, is called coordination number. So these we should not confuse. Here Fe is carrying how much charge? +2. Each side is carrying how much charge? -1. So 6 minus charges, 2 plus charges. Total, this complex will carry 4 units of negative. Thus, to satisfy 4 units of negative, 4 K plus ions come and neutralize the charge. Thus, what is the final formula of the complex? K4 FeCl6, potassium ferrocyanide. What is the name of it? Potassium ferrocyanide. Ferro means the iron oxidation state is +2. What is the ferro complex in your body? What is the ferro complex in our human bodies? Answer: hemoglobin. Hemoglobin is a ferroporphyrin complex. Hemoglobin, what it is? A ferroporphyrin complex in which iron is in +2 state. So the human blood contains hemoglobin. So that hemoglobin is a complex formed by again iron 2+. So without hemoglobin, the oxygen is not carried to the different parts of the body. So every second when we are inhaling oxygen or air, the oxygen goes into your lungs, where the coronary artery will pick up that oxygen from your lungs and become oxygenated blood. This oxygenated blood travels to the various parts of the body, where another protein called myoglobin, which is present in the muscles, it will be waiting there. So this oxygen carried by hemoglobin is transferred to myoglobin. Very complex respiration process in the human beings. Okay, that is a different issue. When you become doctors, you will know more and more about the respiration, the functioning of lungs. Why nitrogen is not nitrogen of the air? Actually, air contains 78% nitrogen, 21% oxygen. We are inhaling air, not oxygen. So your lungs are filled with air, in which a larger percentage is nitrogen. Of course, nitrogen has also 2 lone pairs. Oxygen is also having lone pairs. It is only 21%. This is 78% in air. So which is the larger percentage? But the iron 2 plus of hemoglobin, you don't look at nitrogen. Nitrogen, you form a coordinate covalent bond with me. No. The iron 2 plus only forms coordinate covalent bond with oxygen. So why though nitrogen is in larger proportion, why it is not linked to iron 2 plus of our hemoglobin? Why only the lower value percentage oxygen is linked? That's a very unique respiratory mechanism that I don't explain now, as it is a time waste for us. But in future you are going to learn about it when you become doctors. Okay? Now, this is all what we are looking at now, the questions. So, 3 questions are over. 4th question, the stability of an ionic compound is mostly due to the answer option C, lattice energy. Write a point. Higher the lattice energy, more is the stability of the ionic compound. Higher the lattice energy, more is the stability of an ionic compound. Next question. The number of Na+ ions surrounding each chloride ion in NaCl. 6, option D. The total number of Na+ and Cl- present in the unit cell of NaCl. 4, 4. That we don't know actually. Answer is 4, 4. Which are the following bonds with the most ionic? Yes, this you can answer. Yes, what is the answer? Very good. Cesium chloride, option A correct. So, the all of them are non-metal. B and D are pure covalent. Aluminum and chlorine, metal-non-metal combination. Though it is expected to be ionic, but it is covalent due to the large polarizing power of Al3+. The answer is yes here. Molten NaCl conducts electricity due to the presence of, what is the answer? Free ions, not free electrons. Yes, last question. An electrovalent compound does not exhibit space or stereoisomerism due to. Very good. Answer. Last option, non-directional nature of ionic bonds. Ionic bonds are also called electrovalent bonds. All the questions are direct questions, easy. Now write the next heading, covalent bond. Covalent bond. Actually, covalent bond. It is generally a non-metal atom. Plus non-metal atom combination. condition for covalent bond, non-metal combination. Of course, some ionic compounds possess covalent nature due to high polarizing power of cation, high polarizability of anion. But what is the general condition for covalent bond? A non-metal atom must combine with another non-metal atom. This covalent bond you can classify into three types. First one, non-polar. The second variety, polar. The last variety, multiple. Again, multiple is divided into non-polar and polar. So non-polar, two similar atoms of same element. Same element. For example, hydrogen atom with 1s1 plus another hydrogen atom with 1s1. When both talk to each other, they come to an understanding. Let us form a pair of electrons between us because both of them are having one electron. This single electron become an electron pair. The electron pair is equally shared. And both atoms get stable doublet configuration. Stable doublet configuration. So from this you can define covalent bond is formed due to sharing of an electron pair between two atoms. How a covalent bond is formed? By sharing an electron pair between two atoms. If both atoms are similar, the covalent bond formed is called non-polar covalent bond. Example 2. Two fluorine atoms fluorine is 2s2, 2p5. 7 electrons. Another fluorine, again 2s2, 2p5. Or better, you write the single electron this side, it will be easy for you. Now each fluorine, I wrote 7 dots on that. Out of 7 dots, 3 are paired dots without base. 1 is a single dot. That is unpaired electron. So each fluorine atom is contributing how many unpaired electrons? 1. This contributes 1, this also contributes 1. Then it becomes an electron pair. And that electron pair shared by both fluorine atoms. Now the configuration of each fluorine becomes 2s2 2p6. Stable octet configuration, which is stable neon configuration. What it is? Stable octet or stable neon configuration. Now this type of representations showing electrons as dots are called Lewis dot structures. What these are? Lewis dot structures. Now if you want, you can write one more example under non-polar. H2F2 Cl2. Chlorine also have 7 electrons. 3s2 3p5. It is brother of fluorine. Fluorine has 2s2 2p5. Fluorine has 3s2 3p5. It combines with another fluorine. Again, this is also 3s2 3p5. So each fluorine can contribute 1 electron for bonding, and it becomes an electron pair that is shared equally by both the fluorine atoms. It becomes 3s2 3p6 stable argon configuration. Generally, covalent bond is indicated with a line or dash between the two combining atoms. You can also represent like this. But in ionic compounds, you can't write a dash because the bonds are non-directional. Here, hydrogen also can show like this: H dash H, F dash F. Like this. Now, this is all about non-polar covalent compounds. Now, my question is, what type of intermolecular forces are present between non-polar molecules? Anyone? What type of attractive forces are present between non-polar molecules? Partial van der Waals is a old name. Van der Waals forces is a old name. Now the NCERT textbook is using the new name London dispersion forces. They are also weak forces. Now I connect this point to the chain isomerism of organic chemistry. C4H10 has 2 chain isomers. C4H10 has 2 chain isomers. What are those? So C4H10 has two chain isomers. CH3, CH2, CH2, CH3, 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 CH3. This is called isobutane. This is called normal butane. M-butane, isobutane. Two chain isomers. So why we suddenly gone to that place? Because alkanes are also non-polar. Generally non-polar bonds are formed between similar atoms. Though alkanes, carbon and hydrogen, are dissimilar, alkanes are non-polar because the electronegativity difference between carbon and hydrogen is very small. Carbon has an electronegativity 2.5. Hydrogen is 2.1. Delta EM is only 0.4. That's why the bond is non-polar. Now the question is, by seeing the two structures, normal butane and isobutane, or the second structure in IUPAC, we call 2-methyl propane, IUPAC name, which is larger in size or which has more surface area, which is smaller in size or having less surface area. See the diagram and answer. Between N-butane and isobutane, which has a larger molecular surface or bigger in size. Speak loudly, right or wrong? Very good. You should not be hiding. Right or wrong, you should speak boldly. That is good culture. Keeping everything inside you is a very bad culture. You should spell out. So the answer is N-butane. Write a point. In non-polar molecules, London dispersion forces are directly proportional. Molecular size or surface area so between N-butane and isobutane, N-butane has a larger surface area. That's why it has more London dispersion forces. That's why boiling point of N-butane is greater than boiling point of isobutane. Boiling point of N-butane is greater than. While N-butane has more boiling point, though both are isomers, they are chain isomers, their molecular weight is same. C4H10 means 48 plus 10, 58. Both the same molecular weight 50, but which will have more boiling point? 150. Why? It has largest surface area. So what? With increase in surface area, what will increase? London dispersion forces or van der Waals forces increase. Now if you understand this point, now you answer this. C5H12 has 3 chain isomers. One is N-pentane, N-pentane. The second one isopentane, and the last one it is called neopentane. So it has total 3 chain isomers. I number as 1, 2, 3. So what is the boiling point order? Yes, loudly. Excellent. 1 greater than, 2 greater than 3. Why 1 has more boiling point? Larger molecule having more surface area. The second one has a single branch, surface area decrease. The third one has a double branching, middle carbon has 2 branches. So it is still smaller molecule. So the boiling point order is 1 greater than, 2 greater than 3. Now melting point of isopentane is greater than melting point of N-pentane. Similarly here also, boiling point you have already answered. You write the melting point, it is exactly the reverse. So I have given the answer, you have to give the reason why melting point is reversed. Write the point. Melting point is related to solid state. Melting point is related to solid state. And in the solid state, more the close packing of the molecules, more the close packing of the molecules, more will be the stability of the lattice, more will be the stability of the lattice, and higher will be the bending point. Good, sir. Next. Next point, in isomeric alkanes, with increase in the size of with increase in number of branching, or with increase in branching, not number, with increase in branching, the molecular size decreases. In alkanes, with increase in branching, the molecular size decreases, and smaller molecules are more closely packed in the lattice, and smaller molecules are more closely packed in the lattice and will have higher melting point. Okay, please look at the board. Now between all these three, or among these three, this is a small molecule, this is somewhat big molecule, this is even bigger molecule. So since it is very small, it is solid state, these molecules are more closely tightly packed. The more the tight packing, more difficulty to break the lattice. Bigger molecules are loosely packed. Smaller molecules are closely packed. That's why the melting point always reversed. There also got reversed. So here, in chemical bonding chapter, we have touched one point related to the boiling and melting points of isomeric alkanes. Because alkanes are non-polar. What are the type of attractive forces in non-polar molecules? Random dispersion forces, which are very weak. And these random dispersion forces are directly proportional to the surface area of the molecule or the molecular size. So based on that, we are able to predict the boiling and melting points of isomeric alkanes. Clear? Next heading, polar covalent bond. Polar covalent bond. Clear point? Unequal sharing of electron pair unequal sharing of electron pair between the two combining atoms. Between the two combining atoms. Results in polar covalent bond. Results in polar covalent bond. Generally, this is possible if the combining atoms are different. Continue that. Generally, this is possible if the combining atoms are different. at this, H is here. So this is 1s1, this is 3s2, 3p5. Now they talk to each other. Hydrogen says, my dear chlorine, I can contribute a single electron for bonding. Chlorine says, yes, I have also one electron I can contribute. So total how many electrons are contributed? 2. Then become an electron pair. That electron pair is shared by both hydrogen and chlorine. With respect to hydrogen, the configuration becomes 1s2. With respect to chlorine, the configuration becomes 3s2, 3p6. Now both are happy. Hydrogen got stable doublet or duplet configuration. Chlorine has got stable octet or organ configuration. But after this sharing, the electron pair is more pulled by chlorine. Chlorine has the nature of pulling the bonded pair towards itself. That is called electronegativity. So when the electron pair is more attracted towards chlorine, when the electron pair shifts more close to chlorine, chlorine gets a partial negative charge. Hydrogen gets partial positive charge. You get two poles, a negative pole and a positive pole. Thus a molecule is called polar molecule. Because two poles are developed. One is a negative pole on more electronegative atom, positive pole on less electronegative atom. You get a dipole, two poles are formed. Thus a molecule is called polar molecule. And the bond is called polar covalent bond, which is formed by unequal sharing of electron pair. Why the electron pair is not equally shared, as in case of non-polar? Why here it is unequally shared? Because one of the combining atoms have more tendency to pull that bonded pair or shared pair towards itself. That property we call as electronegativity, that we have already studied in our previous lesson. So that electronegativity is measured in certain scales called Mulliken scale, Pauling scale. What is the value of electronegativity of chlorine on Pauling scale? 3.0. What is the value of electronegativity of hydrogen, which is taken as a reference element by Pauling? 2.1. So what is the electronegativity difference in HCl? 3 minus 2.1. How much it is? 0.9. Now I will give another example. HF. So an electron pair is formed. That electron pair is pulled by fluid. Thus, after the formation of HF, fluorine gets partial negative charge, hydrogen gets partial positive charge. This is the second example. Third example I will do fluorine chloride, FCl. F plus Cl. This is 2s2, 2p5. This is 3s2, 3p5. Both are brothers, same group. They are called halogens. So fluorine contribute 1 electron. Fluorine also contribute 1 electron for bonding. So a bond is formed between fluorine and chlorine. Each atom acquires stable octet. This becomes 2s2, 2p6. This becomes 3s2, 3p6. Now both are happy. So after that, formation of fluorine chloride. Fluorine chloride. The bond formed between them. Fluorine will have delta negative. Fluorine will have delta positive. Because between fluorine and chlorine, which is more electronegative? Fluorine. Perhaps fluorine is the most electronegative element in the periodic table. Fluorine is the worst element in the beginning because the fluorine atoms are small size. It has highest electronegativity. And the bond dissociation energy between F and F is very small. 36 kilocalories per mole. So regarding fluorine, there are three negative things in terms of human beings. The atoms of fluorine are very small. Fluorine is the highest electronegative element in the periodic table. And one more bad news about fluorine. The molecule, the bonds are easily broken because of the repulsions of the lone pair repulsions on the small size fluorine atoms. LP repulsions. So why the bond is weak in fluorine? Because two fluorine atoms are being very small. They are very close to each other. When they are too close to each other, the lone pair repulsion starts. That's why they want to repel and go away from each other. When they want to move away from each other, the bond becomes weak. So because of these three factors, when the scientists came to know there is an element called fluorine, they tried to isolate it from its minerals like fluorspar, fluorapatite. Some fluoride minerals are available. They want to recover fluorine from those available resources. But those whosoever attempted to separate fluorine mercilessly killed them. So many scientists lost their lives in attempting to isolate fluorine from its minerals because of its highest reactivity. Why it is the highest reactive? Three reasons: low bond dissociation energy, small atomic size, highest electronegativity. So write that point, it is on the syllabus. The highest reactivity of F2 fluorine is due to number 1, small atomic size. Number 2, highest electronegativity. Number 3, dissociation energy. Very low bond dissociation energy. Within brackets 36 kilocalorie per mole. So because of these three factors, it is highly reactive, and whosoever attempted to recover or isolate fluorine, it mercilessly killed them. That's why people are worried to separate fluorine or to extract fluorine. Finally, a French chemist, Moissan, his name, M-O-I-S-S-A-N, a French scientist, Moissan, he first isolated fluorine. And with a lot of excitement, he came to the Paris Chemical Institute, and a big gathering was there. With a lot of excitement, he explained how he is able to isolate fluorine. But while explaining, people observed his lot of bone injuries on his face. His hands are also burned. Because whenever fluorine comes in contact with skin, it causes severe burns, and it removes the calcium ions from your muscles. So the burns caused by fluorine are difficult to heal also, because calcium is removed. So accidentally, luckily, Moissan was escaped to death. With a lot of bone injuries, surgical bandages, he came to Paris Chemical Institute and read the paper explaining how he was able to isolate fluorine. So fluorine is very dangerous. That's why generally in the labs, we don't store fluorine in the form of fluorine. We store fluorine in a different form called interhalogen compound, like fluorine chloride, like chlorine trifluoride. Directly fluorine is not stored in tanks. Why? If any gas leakage occurs, this extremely reactive gas will cause a devastation in the surrounding areas. Like the mic gas. What is mic gas? Anyone? Mic gas, you don't know? Methyl isocyanate. Popularly called as MIC. Is 44 hours. Because Andhra Pradesh to Delhi it is 26 hours. From Delhi to Jodhpur it is another 18 hours. 42-44 hours journey. In between we used to cross the Bhopal station, Madhya Pradesh. So in Bhopal, there is an American company called Union Carbide Factory. That Union Carbide Factory is a pesticide manufacturing company. So there for making pesticides, they stored this methyl isocyanate, CH3MCO, in big tanks. Now accidentally, on a fateful night, this mic gas is leaked and surrounded the entire area of the factory. People don't know, night time they are sleeping. So they inhaled this gas. People died in large numbers, thousands. Some people who had a little exposure has a dangerous side effects for their body. Even today, this happened in 1986. While I am telling this story, we are also traveling on the same route. Our train has just, before a few hours, it has crossed the Bhopal station. In Bhopal station you can see the Union Carbide flag. So, many thousands of people died. Lives of thousands of people were crippled with a lot of side effects. Because the Americans pressurized the government, Congress government at the center. Don't arrest the chief of the Union Carbide factory and safely fly him to America. So Mr. Anderson, the chief of the factory, first he was airlifted from Bhopal to Delhi. Delhi to he flew back to his own country. There was a big legal case in the Supreme Court, and finally the victims of Bhopal gas has won the case, and the American company Union Carbide has paid lots of money to the people who died, to the relatives, and people who totally has affected their lives permanently. They received huge money from the company. But it is a devastating effect in the entire country. 1986, Bhopal gas tragedy. So what is that gas? Methyl isocyanate. Actually, the only precaution the factory failed to give to the people, if at all this methyl isocyanate is leaked, just they can keep a wet kerchief before their mouth and nose. It is hydrolyzed and its toxicity is gone. But the simplest safety measure, they fail to inform to the neighboring people. Whenever this type of gas is leaked, what they have to take? A small cloth, wet cloth, cover their face, cover their mouth and nose. If at all the gas is going inside, it undergoes wetness, it undergoes hydrolysis, and toxicity is gone. That is small instruction they made. So it costs a heavy cost. Many lives are gone. So why I am telling, fluorine is extremely reactive and most dangerous gas. Finally, when Morrison prepared with a lot of burn injuries, later many scientists revised the methods, and nowadays fluorine is converted into the most stable fluorocompounds. Though fluorine is very reactive, fluorocompounds are the least reactive. Fluorine is extremely reactive, but fluorocompounds are least reactive. Can you name one fluorocompound which is the least reactive we use in our regular daily life? Teflon. Polytetrafluoroethene. Teflon. Lentiles. It's a polymer. Those are your dendrites. What is this Teflon? It is a polymer. Very stable, and most unreactive. That's why people are used to make Teflon coated vessels for our cooking purpose. If you want to make any non-stick cooking ware, you want to make a dosa, omelette, it should not stick to the pan. So non-stick cooking utensils came into the existence. They are coated with this material, Teflon. Though under hot condition with oil and other ingredients, it won't react. Thus, Teflon coated vessels are very much abundant nowadays, everywhere. They are flooded in the market. But recently, maybe 10 years back, the American FDA has given a warning. Don't use Teflon coated vessels. It is carcinogenic. They are carcinogenic. Cancer creating. Thus, if you have at your home any Teflon coated vessels, in market they will take for second hand trade. You just give them back and just purchase either cast iron vessels or stainless steel vessels. Teflon coated vessels are very dangerous. They are carcinogenic, cancer creating. But if you purchase a new car, especially in Meghalaya, this is not, because rains are more here. The car parts, bottom parts, they get rusted. Whenever rains are more, the metallic parts of the car gets easily rusted. The life of the car decreases. That's why whenever you purchase a new car, the showroom people will ask you, better have a Teflon coating. They take your car to the workshop, they will seal it, or there is a airtight chamber in which the car is kept, and it is totally coated with a Teflon, a non-corrosive plastic. Your car parts are not rusted. So Teflon you can use for that. But even today our Indian market is having Teflon coated vessels. Don't use it. As per American Oncology Association, this American Cancer Association, industrial pollution, plastics, Teflon coating are the three prime reasons. High voltage electric lines. These are the four potential triggering factors for cancers. What are the four? Excessive usage of plastic in our daily life. Second one, Teflon coated vessels. Third one, high voltage electric lines. Fourth one, environmental pollution. Luckily in Meghalaya, environmental pollution is zero or less than zero. They go. Especially you don't know the other Shillong area, especially one non-star, this area, Boyd district, is almost zero polluted. You are lucky. But don't use plastic bottles. So mostly you are using, some of you are using plastic bottles or Tupperware. Both are dangerous. So convert into steel bottles. You can use for some days, slowly change it. Don't throw immediately. Now, write a question. The type of bonds is a previous JEE question, but NEET level only. The type of bonds in bromine chloride. In bromine chloride. Bromine chloride. CHLORIDE. Within brackets BRCl. BRCl. Option 1. Purely ionic. Option 2. Non-polar covalent. Option 3. Polar covalent with a negative end on bromine. Polar covalent with negative end, END. Negative end on bromine and positive end on chlorine. Now last option, polar covalent with positive end on bromine, negative end on chlorine. Yes, anyone open? Option? Option 4. Dr. Rocky is correct. Bromine and chlorine different atoms. Whenever the covalent bond is formed between different atoms, it is polar covalent. Since chlorine is more electronegative, it carries negative charge, negative end. Bromine carries positive charge. Right, the next. The most important property exhibited by polar covalent compounds. The most important property exhibited by polar covalent compounds is dipole moment. Dipole moment mu. So mu is equal to E into D. E is magnitude of charge. On any one of the pole. Magnitude of charge on any one of the pole. D is the distance between the two poles. Which is nothing but bond distance. So by this formula, we can define dipole moment. Just I gave a formula. I have not yet defined, but we can define. So dipole moment is a product of the magnitude of charge on any one of the poles of a polar molecule and distance between the two poles. And distance between the two poles. So what is dipole moment? It is a product. Product of what quantities? Two quantities. What are those two quantities? We are multiplying magnitude of charge on whom any one of the pole. Because dipole One carries negative pole, the other carries positive pole. On any one of the pole, you have to take the magnitude of charge into distance between the two poles. If you multiply both, you get dipole moment. Actual magnitude of charge is measured in electrostatic units into distance in centimeters. That is ESU centimeters. This is units. Actually charge is in the order of 10 power minus 10 electrostatic units, and the distance is in the order of 10 power minus 8 centimeters. So when mu is equal to E into D, we write 10 power minus 10 ESU. ESU means electrostatic units into 10 power minus 8 centimeters. So 10 power minus 18 ESU centimeters. This 10 power minus 18 electrostatic unit centimeters is called 1 dBi. DBi is also the unit of dipole moment. DBi is also the unit of dipole moment. 1 dBi is equal to 10 power minus 18 ESU centimeters. Write the next point. Dipole moment is a vector quantity. Dipole moment is a vector quantity. That is, its value depends on the magnitude of the charge its value depends on the magnitude of the charge and the direction and also the direction of the bond. So whenever a particular quantity depends on both magnitude and the direction, we call it as vector quantity. So dipole moment is a vector quantity. What it is? Its value depends on not only the magnitude of the charge but also the direction of the bonds. For all linear molecules, next point, for all linear molecules, the net dipole moment is 0. As the individual dipole moments as the individual dipole moments of the bonds, as the individual dipole moments of the bonds within brackets bond moments, the individual dipole moments of the bonds within brackets bond moments cancel with each other. Cancel with each other in the vectorial addition. Look at this B is here. B is here is a linear molecule. And this bond will be acting in this direction. According to the bond way, this bond will be acting in this direction. So these two vectors means two bond moments cancel with each other. Since they cancel with each other, net mu is equal to 0. When net mu is equal to 0, we call it as non-polar. So here the point is, barium chloride has two polar covalent bonds. Though it contains two polar covalent bonds, the molecule has ever become non-polar. Why it became a non-polar molecule in spite of two polar covalent bonds? These polar covalent bonds are projected in opposite direction. This vector and that vector will cancel with each other. You have well known the vectorial additions in your physics. In physics you have vectors chapter. There you are studying vectorial additions and you are more knowledgeable in vectorial addition than me. So second example I give, carbon dioxide, CO2. Mu is equal to 0. Mercury to chloride. Mu is equal to 0. Xenon dichloride. Mu is equal to 0. Whenever mu is equal to 0, they are non-polar. For all symmetrical molecules, mu is equal to 0 and they become non-polar. Here boron is surrounded by 3 fluorines. With 120 degrees bond angle. It is a symmetrical molecule. Now this vector acting in upward direction is cancelled by the resultant of these 2 vectors. Resultant of these 2 vectors act in the opposite direction. So the net mu is equal to 0. It is non-polar. This is BF3 molecule. Please look at it. This is BF. 3 fluorines are here. Center boron is there. So this vector is acting upward direction. This vector, resultant of these 2 will act in the downward direction. So the upward vector and the resultant of this, they cancel with each other. So net mu of BF3 is equal to 0. It is a non-polar molecule. Whenever mu is equal to 0, non-polar. Now here I will show one more illustration. Now I put another pen here and make a tetrahedral arrangement. That is how I am showing the molecule of CCl4, carbon tetrachloride, or SiCl4, silicon tetrachloride. So one Cl vector is acting upward. The resultant of these 3 will act downwards. The resultant of these 3 vectors, one vector up. This vector and the resultant of these 3 will cancel with each other. So net mu is equal to 0. So CCl4 is non-polar because its net mu is equal to 0. CCl4. In geometrical isomerism, trans isomers have 0 dipole moment. Dichloroethene. Now I am writing this product. This is going to be trans. 1,2-dichloroethene. These 2 are geometrical isomers. Are also called diastereomers. at the cis form, this bond, with both the vectors, this here vector, this here vector, both are acting in the same direction. So mu is not equal to 0. That's it is prolonged. Look at the trans isomer. So here two vectors are acting in opposite directions. So mu is equal to 0. It is non-polar. So between cis and trans isomers, which will have zero dipole moment, so trans isomers have zero dipole moment. Whenever dipole moment is zero, it is non-polar. Write a point here. The type of intermolecular forces in polar molecules intermolecular forces in polar molecules are strong dipole-dipole attractions. What is dipole? The molecule carrying both negative and positive poles is called a dipole. The molecule having both a negative pole and a positive pole is called a dipole. Now this dipole is attracted by another dipole. So what happens? Whenever HF is there, this positive and negative will attract with each other. Similarly, this positive, this negative will attract with each other. That's how this dipole will attract with this dipole. So that's why the forces are called dipole-dipole attractions. Which are strong. Now we have come across two types of intermolecular forces in polar molecules, strong dipole-dipole attractions. In non-polar molecules, weak London dispersion forces. So it is obvious, you can tell that when compared to a non-polar molecule, a polar molecule will always have higher boiling point. Because in non-polar, what are the attractive forces? Weak van der Waals or London dispersion forces. What are the attractive forces between polar molecules? Strong dipole-dipole attractions. So now we compare cis-butane and cis-dichloroethene and trans-dichloroethene, which will have more boiling point vary. So here you are right, more boiling point, less boiling point. boiling point due to strong dipole attractions. Why its boiling point is less? Due to weak London dispersion forces. London dispersion forces. Which will have more water solubility between these two? Polar molecules are more soluble in water. So cis isomer, which has polarity, is more water soluble than trans isomer. Right, the next question. In isomeric dichlorobenzenes, the decreasing order of dipole moment dichlorobenzene. This is meta-dichloro. Meta-dichlorobenzene. This is para-dichlorobenzene. So in Amilpac system, first one is called 1,2-dichlorobenzene, second one is called 1,3-dichlorobenzene, the last one 1,4-dichlorobenzene. Here the two vectors and the resultant vector will be in this direction. So here mu is more. Here mu is somewhat less because the vectors are not acting in the same direction. Here the two chlorines are exactly opposite. Mu is equal to 0. So if I give numbering 1, 2, 3. So mu order 1 greater than 2 greater than 3. Next question. Now write a assertion type question. Assertion. Mu of NH3 is more than NF3. Though the NF bonds are more polar, reason in NH3 the bond moments of the three NH bonds and lone pair act in the same direction. So when you compare ammonia and nitrogen trifluoride, so NH3, which is a pyramidal molecule, NF3, which is also a pyramidal molecule, here we are comparing the mu for both the molecules. It is very much asked in the exams. Many exams have asked. Very important question. Here, M is more electronegative than H. What is the electronegativity of nitrogen? Yesterday we gave 3.0. What is the electronegativity of hydrogen? 2.1. So which is more electronegative? Nitrogen. Thus the three bond moments act towards center. The lone pair will act in the upward direction. Overall, total everything is towards upward direction. So its mu is more. But here, the electronegativity of F is 4.0. So the bond is towards fluorine. So here in NF3, three bond moments act downward, lone pair act upward. There is some cancellation. So mu is equal to mu is less. Why in ammonia it is more, why in NH3 it is less? In ammonia all are acting in the same direction. All are means what? The three NH bonds and one lone pair. All will be acting in the same direction. The beam process, the vectorial addition, causes more dipole moment. But in NF3, the three bond moments of NF bonds act downward. Lone pair act upward. That is the reason. Write the next question. What is the decreasing order? Dipole moment of CH3Cl CH2Cl, CHCl3, CCl. So the order, new order is 1 greater than, 2 greater than, 3 greater than 4. Reason. Write the reason. As the number of chlorine atoms, on the carbon increases, as the number of chlorine atoms around the carbon increases, in the vectorial addition, cancellation occurs. Around the tetrahydrocarbon. Look at this. Here I have taken 3 black cap pens, 1 blue cap pen. That is, this black cap indicate H, center carbon, CH3, 1 is chlorine. Now in this CH3Cl, the first molecule, methyl chloride, what happens? Only one chlorine will pull the electron pair, and because of this, the dipole moment arises. Now you replace one with one more chlorine. Now the molecule becomes CH2Cl2. Methylene chloride. What is its name? Methylene chloride. So one more chlorine increase now. This vector, the vectorial addition, they don't cancel with each other. Slightly they cancel with each other. Thus the dipole moment decrease. Suppose one more chlorine, CHCl, chloroform, some more cancellation of these vectors, still decrease. All 4 chlorines, the upward vector and resultant of the 3 cancel. Net mu becomes 0. So in the substituted chloromethanes, what is the decreasing order of mu? CH3Cl greater than, CH2Cl2 greater than. Similarly, yesterday some student also asked me now, CH3F, CH3Cl, CH3Br. I think Dr. Tommy asked this. Now what is the compounds here for given? Fluoromethane, chloromethane, bromomethane, thiomethane, iodic system, or methyl fluoride, methyl chloride, methyl bromide, methyl iodide. Which is the most electronegative? Actually, generally, whenever more electronegative atom like fluorine is there, it should have more mu. But very interestingly, here the mu order 2 greater than 1, greater than 3, greater than 4. This is the order. So write a point. Though fluorine is more electronegative, than chlorine, though fluorine is more electronegative than chlorine. Why? Methyl chloride. Why methyl chloride? Will have higher dipole moment than methyl fluoride. What is the reason? Dipole moment depends on two quantities. They are number one, magnitude of charge. They are number one, magnitude of charge within brackets E. And number two, distance, that is D. In CH3Cl, as the CCl bond distance is a more dominating factor in CH3Cl, the CCl bond distance is a more dominating factor than magnitude of charge. Hence its mu is more. Hence its mu is more. Very important, this is given in NCERT textbook, this particular example. So write important or star mark. Whenever I say important or star mark, you have to read many times that one. Now take a short break. After that we will continue. E or 2, the distance between the two poles. So now mathematically, mu is equal to E into B. This already mentioned already. 1 pi is equal to 10 power minus 18 AC centimeters. Or you can also add one more point. 1 pi is equal to 3.335. This one. This also you can mention. In coulomb meters also. Coulomb meter. Then you SI unit. Vector quantity, we already mentioned all these things. So last 2 points. In case of polyatomic molecules, there are more than 1 polar bonds. So dipole moment is equal to, we write this one. In polyatomic molecules, there are more than 1 polar bonds. So dipole moment is equal to resultant dipole moment of all individual polar bonds, which contribute to bond moments. This we already used this sentence. Which contributes to bond moments. This also can add one more point. Mu resultant is equal to this point. Mu R means resultant. Mu R is equal to mu of which one? This point. In case of polyatomic molecules with more than 1 polar bond, resultant dipole moment, where you write net mu is equal to vectorial addition of individual bond moments. Net mu, same point meaning this one. What? Can I guess? Resultant dipole moment may be calculated for the point already wrote. Just write the formula. Mu resultant is equal to root of mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. where theta is the bond angle. So after writing this, theta is equal to bond angle. If theta is equal to 0, the resultant mu is maximum. If theta is equal to 180 degrees, the resultant is minimum. Only 2 parts here. Dipole moment of water is 1.84 divide. So mu of water divide, which indicates water cannot linear structure. You can't write water like this. Why you can't write water like this? If it has linear structure, mu should be 0. So whenever mu is not equal to 0, it cannot have linear structure. Next. The molecules have resultant dipole moment, zero dipole moment, said to be non-polar. We already wrote that. So write example only. Example with mu is equal to 0. Here more examples are mentioned. CO2, BeCl2, BeF2, CS2 carbon disulfide, BF3, BCl3, CH4, CCl4, all these have mu is equal to 0. When mu is equal to 0, they are all non-polar. Next, try this example. Molecules with mu not equal to 0. Molecules with mu not equal to 0. H2O, they have given the value 1.84 divide. Ammonia, they have given 1.40 divide. NF3 only 0.24 divide. CH3Cl 1.86. Molecular geometry and dipole moment. General formula AX type. Geometry is linear. May be non-zero, like HF, HCl, HBr, HI. Second, AX2 type, if they are linear, dipole moment is zero. Example, these molecules. This table will complete now. AX type molecules, though they are linear, they are not having zero dipole moment. Like hydrogen halides, we have given HF, HCl. We can also write HBr and HA. Second, AX2 type molecules, they are also linear. CO2, CS2, BeF2, you can add one more, HCl. Xenon dipole. Can I move? So finish the entire table. AX3 type. Trigonal planar. So 0, BF3. Again AX3 type, second variety pyramidal molecules. Dipole moment is greater than 0. Ammonia, PCl3, NF3. T-shaped molecule. There is a small mistake here. AX type, AX6 type, octahedral. SF6, and it is 0. Distorted octahedral, you write non-zero. Here HCl6. This is a mistake. Just AX7 type pentagonal bipyramidal 0X7. Applications of mu. Applications of mu. Number one, don't write all this. To know the extent of polarity. Extent of polarity. Greater the value of mu, greater is the polarity. Application 2. Percentage calculation of percentage ionic character. Calculation of percentage ionic character. In fact, only write this formula. Percentage ionic character is equal to percentage ionic is equal to mu observed. That can also be expressed in a different way. Mu observed by mu for 100% ionic into 100. So write this formula, write this one also. Write one problem based on this. The observed mu value of HCl is equal to 1.03 divided the bond distance is equal to 1.27 angstroms. 5% ionic. 5% ionic character. So I use this form. Both are same. This is easy to understand. What is mu observed? 1.03 divided by in the denominator I wrote mu for 100% ionic. What is actually mu? E into D. What is mu? E into D. To get 100% ionic character, the charge value should be 1 unit. 1 unit charge value is always 4.8 into 10 power minus 10 ESC. Into distance already given. How much? 1.27 into 10 power minus 8 centimeters. Here also this above numerator is in divide. This divide to convert into ESU. 10 power minus 18 ESU centimeters into 100. So 10 power minus 18, 10 power minus 18 cancels. So what is that? 1.03 by 4.8 into 1.27 into 100. This is simplified. Simplify this fraction. You will get around 16.9. This value you get checked. So whenever a problem is given to find out the percentage ionic character, what you have to do? In the numerator, the given mu value. In the denominator, to get 100% ionic, you have to take 1 unit charge value. 1 unit magnitude is 4.8 into 10 power minus 10, that they don't give. Students should know from fundamentals. To get 100% ionic, 1 unit charge must be there. What is the value of 1 unit charge? 4.8 into 10 power minus 10, that is E value. In the distance value, they are already given. So what is the formula I am using? Percentage ionic character is equal to mu observed by mu for 100% ionic into 100. Mu observed is 1.03 divided by denominator. To get 100% ionic character, you have to take one full unit charge, that is 4.8 into 10 power minus 10, into the bond distance 1.27 angstroms into 10 power minus 8 centimeters. So on simplifying, you are getting the percentage ionic character of HCl as 16.9. System plant systems will already discuss. This also discussed actually. Ortho greater than meta greater than para. Is it over? Is equal to 2 into bond moment into x cos theta by 2. What is x here? There are here. Okay. Seventh point. We will look at the seventh point. Dipole can be used to predict hybridization. The molecule AB2 mu is 0 and the atomic number is less than 21. Okay, that we already discussed. CO2 BF2 no 0. No, already we discussed all these points. Yes. So points or sub areas we will discuss in tomorrow's class. Tomorrow my flight is at 2:30. I can take 9:30 to 12:30, no problem. The airport is nearer to SAR. Don't you know? It is only 15-20 minutes drive. So, I think hope we are also free tomorrow 9:30 to 12:30. Or some other lecturer is coming. Physics, biology. Then we will do one thing. Tomorrow we will cover hybridization, BSc, PR3D, coordinate covalent bond, metallic bond, hydrogen bond. Up to that I think we can cover. Only last parts, bond characters.